Welcome to today's Explainer. We are jumping right into a really fascinating piece of source material today. It's a preliminary evaluation of the aluminum plant. We're going to examine a brief but incredibly revealing online journal entry that outlines what I like to call an active, kind of lazy but strategic botanical experiment. Seriously, it's a brilliant look at how a structured, totally hands-off approach can actually yield some super actionable data for us.
Okay, let's dive into this. Right away, our source material greets us with these two simple words: Dear Interweb. I love this because it instantly plunges us directly into the personal, ongoing diary world of our protagonist here. They're a super methodical gardener who just goes by the name Ang. You know, this isn't some dry, academic, scientific paper. No way. This is an active, ongoing log. It feels intimate, and it really tells us that we're stepping right into the middle of this continuous journey of observation.
And just listen to the sheer scale and dedication of Ang's gardening passion. I mean, this is clearly not just a casual weekend hobby. This entry is literally titled Notes on Gardening, Part 922, and it was published on June 11th, 2026. That tag alone gives this whole explainer a real-time, almost captain's log kind of feel. We're following a dedicated archivist of plant behavior, someone who has meticulously cataloged over 900 observations before we even join the story today. Just wow.
Section 1. Meet the aluminum plant, formerly known as pilea-cadierei.
So, to kick off this early evaluation, Ang acquired exactly 2 specimens. Just 2. Why 2? Well, to properly assess a plant's behavior across different environments, you absolutely need a baseline of comparison, right? By securing exactly 2 of these aluminum plants, and at a very affordable price, which Ang definitely makes sure to note, our gardener has set up the perfect minimal test to conduct a genuine comparative experiment without breaking the bank.
Now, what's really interesting here is that the likelihood of these 2 specimens doing well is actually quite high right from the jump. Ang notes these specific baseline traits. Obviously, they're affordable, but most importantly, the literature shows this species absolutely thrives in bright indirect light. Because Ang already knows this plant's baseline preference, the foundation for success is already there. But, as we all know, knowing what a plant likes on paper and seeing how it actually survives in a specific garden, yeah, those are 2 completely different things.
Moving on to Section 2. The microclimate experiment.
Here we have the plant's natural inclinations, thriving in that bright indirect light, contrasted directly with Ang's strategic testing plan. Ang's stated goal is to assess the plant's suitability for different gardening areas, specifically testing them under varying microclimates. By placing these 2 affordable specimens in different specific spots, Ang is basically conducting a localized stress test. They're mapping exactly how adaptable the aluminum plant truly is when you take it out of the cushy nursery and drop it into the wild reality of a home garden's unique zones.
And this brilliantly illustrates the methodology behind the madness. Ang's specific gardening style for this test is gloriously minimal. We're talking little to no fertilizer, merely occasional watering, and growth that is allowed to proceed entirely naturally. It's a delightfully low-effort, hands-off approach. Honestly, it's like a brilliant scientific rebranding of simply ignoring your plants. Ang is deliberately removing the variable of human coddling here. The survival and thriving of these plants will depend entirely on their placement in those microclimates and their own rugged resilience, not on constant gardener intervention.
Section 3. Aging and propagation plants. Based on Ang's reading, they anticipate a very specific natural problem. The plants are inevitably going to get leggy. Legginess is a structural condition that this plant just naturally develops as it ages. The stems stretch way out, the foliage gets sparse, and the plant totally loses that nice compact shape. Ang knows this impending structural issue is coming down the pipeline, which perfectly sets up the need for a strategic gardening intervention later on.
Let's see how this builds into Ang's specific timeline for dealing with that eventual legginess. Step 1, let them grow naturally in those microclimates. Step 2, wait a few months. Seriously, Ang is deliberately holding off right now. And finally, Step 3, begin the actual propagation. This is absolutely a masterclass in patience. Ang is allowing the plants to fully mature, totally expecting them to get leggy, before swooping in to take the necessary steps to renew them.
So, the crucial point is this. When that legginess finally sets in, Ang's research confirms that, quote, propagation by cuttings is the fastest and most suitable approach. Taking cuttings is the ultimate, evidence-based remedy for the aging aluminum plant. Instead of fighting the plant's natural aging process, Ang's plan is to simply let it age, snip the cuttings, and start the cycle all over again. It's an incredibly efficient way to multiply those initial 2 affordable specimens.
Well, that wraps up the current preliminary findings of this fantastic hands-off microclimate experiment. The entry concludes with this wonderfully wholesome, classic diary-style farewell. Till the next post, yours truly, Ang. It's such a great reminder that this is just one single data point, entry 922, in a massive, ongoing journey of botanical discovery.
Which leaves us with a final, burning question. Will the aluminum plant actually manage to thrive under Ang's strict regimen of little to no fertilizer and only occasional watering? Will those two specimens conquer their respective microclimates, or will that natural legginess completely overtake them before the cuttings can even be made? We have the methodology, we've got the baseline traits, but only time and part 923 of Ang's notes will reveal the true outcome. Keep observing, keep learning, and I'll catch you in the next explainer.